Stan Gibilisco here with installment number 2 of the Imaginary Number Primer. As we said in the first video in this series, the unit imaginary number is the positive square root of -1. And maybe I didn't emphasize sufficiently that we're talking about the positive square root of -1. Now, you might ask, does it matter? When you talk about the square root of a quantity, say the square root of 4, does it matter whether you're talking about the positive or the negative? Well, of course it does. If you square the quantity -2, you get 4. If you square the quantity 2, you get 4. So when you talk about the square root of 4, you've got to be very careful to specify whether you mean the positive one or the negative one, or whether you want to talk about them both. If you want to talk about them both, you put a plus or minus sign in front of the radical. If you want to talk about the positive square root, you generally don't need to put anything there. Just like if you talk about 5, just about everybody knows you mean to talk about positive 5. If you want to talk about the negative square root of 4, that one is -2. Okay, now that we've got that cleared up, the big question is this. Does I equal -I or not? It might seem at first like, well, of course they don't equal each other. But wait a second. How do you know? Because we're talking about a brand new thing here. This is not a real number of the type that we've ever encountered before. It's some completely different animal. You might, talk about the rational number 0. Does 0 equal -0? Well, yes. 0 does equal -0. And there might be some other kinds of numbers that are also equal to their own negatives. Question is I one of those? Let's find out. Let's use a technique that you've probably heard about if you've taken any courses that involve proving mathematical theorems. Reductio ad absurdum, which means it's Latin for to reduce to absurdity, or to use logic to derive nonsense. If we can use logic or perfectly valid mathematical rules to derive either a false statement or a ridiculous statement from this, then we know that this statement is false. If we can't succeed in deriving nonsense from this, we cannot come to any conclusion. We have to prove it one way or the other. Is it or is it not? I often like to use that symbol to indicate questionable equality. I don't believe that's a formal mathematical definition, but we can use it here because we don't know yet. But let's assume that this is, in fact, true, that I and -I are identical, they're equal. Then let's see what happens if we manipulate this statement. Let's, for a moment, multiply each side of this equation by the same quantity. We can multiply it by, say, 3. We'll get a true statement. We could multiply it by -6. We could get a true statement. The rules of algebra allow us to multiply anything on the right or on the left and get a true statement if the original statement was true. So, we've taken our original equation, I equals minus I, and multiplied it on the right on both sides by I, getting to this. We know that this is true now, according to our assumption anyway. We know that that is true. What is I times I? Well, that's I squared. What is minus I times I? Well, let's manipulate this just a bit. When you have a negative quantity times a positive quantity like that, basically we're talking about this. We can rearrange the parentheses in an expression like that and get this. Because in general, in algebra, if you have a quantity minus x times y, that equals minus the quantity x times y for any two x and y. So now we've reached this stage. Remember though that I times I is I squared. So now we have the expression I squared equals minus I squared. I put the parentheses there just so that we don't confuse ourselves. So that we know that we're taking the negative of I squared, not the square of negative I. So here's what we have now. Well, remember that I squared, I being what we defined as the unit imaginary number, is equal to minus 1. I squared equals minus 1. So we have this. Of course, the negative of a negative is the positive, so we have derived this statement. Minus 1 equals 1. That is a clearly false statement. The fact that this is false forces us to conclude that that statement is false, so I is not equal to minus I. Now we haven't said anything more than this. Don't read any more than that in there. 2 is not equal to 5. 2 is not equal to minus 2. But there's a big difference. 2 and minus 2 are like mirror images. 2 and 5 are, of course, not like mirror images. So now I guess the question becomes, are those like mirror images of each other or not? All this may seem like what they call splitting hairs or semantics, but it's very important because it brings us to a conclusion. We now know that we should never assume that I equals minus I. We know that it doesn't. Even though I squared equals minus 1, what does minus I squared equal? Well, minus I squared equals minus I times minus I equals minus 1 times I times minus 1 times I. And remember, the commutative property of multiplication allows us to rearrange that into minus 1 times minus 1 times I, or that's equal to 1, and that's equal to I squared. So that gives us I squared, which equals minus 1. So we know now that I squared equals minus 1. And we also know that when we square negative I, we also get -1. Even though I and -I are not the same. But of course that's not really that strange, because after all, 2 squared equals 4, and -2 squared equals 4. We don't think that's strange. We shouldn't think this is strange either. Well, we know it's not strange now because it's true. In the next video, we will learn a little bit more about these strange, fascinating animals called imaginary numbers. And again, by definition, an imaginary number is any real number times I. That real number can be 0, it can be a negative real number like minus the square root of 73. It can be a positive real number like 64, or it can be 0. The interesting thing about 0 is that 0i equals 0. That is to say, in this particular case, we have an imaginary number that's equal to a real number. 0i is the only imaginary number that is also real, and 0 is the only real number that is also imaginary. Just another little tidbit for you to ponder while you wait for the next video in this series. Stan Gibilisco signing off.